So now that we have a basis, so we know this beta here is our basis, and these are our basis vectors. So now we want to talk about the numbers that are in front of our basis vectors to get to our vector x. So there are unique numbers c in front of this specific set of basis vectors. So those unique numbers, those different numbers of c's, are going to be called this is x sub beta, and so these are the beta coordinate vectors of x. So what that means is these are the numbers c's that go in front of your basis vectors to get to the vector x. So you write it like x and then put a little beta as a subscript, and then in that column vector are the numbers c's. All right, so here they're telling us that the vector x is defined by, and it has this as its beta coordinates vector. So this is telling us that what the c's are. So we're here asked to find what the x is. So the vector x will be this number 4 times this first basis vector, this number 3 times this basis vector, and then this number 0 times this basis vector. So just putting it there for effect. It's not necessary to write all that out, but that's what the basis vector, or what the vector is with these beta coordinates. So if I just went to put those together, so I get 4, negative 8, 3, no, I'm sorry, 12, and then negative 15, 0, 6. So this gives us the vector, right? And this is its unique beta coordinates vector. So this is the vector x that has this beta coordinates vector. All right, so let's go the other way. So here's our vector x. So find this vector. So what is that going to mean? That means I need to find the numbers in front of these basis vectors. Isn't that the same thing as saying, so let me write the matrix down here, because we make a matrix out of the basis vectors, right? Isn't that the same thing as saying I'm trying to find the numbers that go in front of the vectors, right? There will be a number times this vector, a number times this vector, and a number times this vector, which means I'm going to be augmenting and solving for these c's. So I put this together in my calculator. So I augment and solve. And so what I get out of this, I'll just write the matrix down, 1, 0, 0, right? This is the augmented matrix. 0, 1, 0, negative 1, 0, 0, 1, 3. Okay, so what this means is that my beta coordinates vector is negative 1, negative 1, 3. Okay, so again, this piece of beta is the matrix that's made out of the basis vectors. So to get to the vector x, we multiply the matrix piece of beta times the coordinate vector. So if I have this piece of beta is a basis, what do I know about a basis? Basis, they're a linearly independent set of vectors that span the set, and this is saying for Rn. So that means it's going to have a pivot every row, pivot every column. So that matrix is going to be invertible, and it's going to be a one-to-one and onto mapping. So everything beautiful is happening for these basis vector, for this matrix in this system. All right, so let's look at this next example. So I'm asking you here to hit, this is the basis. I guess I should have put in these little parenthesis things in here. Okay, find the change of coordinates matrix. So that just means find p sub beta. Well, that just means you're putting these vectors together into a matrix. Oops, 6. I meant negative 4, 3. So there's the matrix, the change of coordinates matrix, using this as your basis vectors. All right. So here we're saying, here are the basis vectors. So I could find my matrix, p sub beta. and that's 1, -3, -2, 5. Okay, so this is saying use an inverse matrix. So you know you can augment and solve, right? So you would augment and solve just like we did on the previous problem. So you could say 1, -3, -2, 5, right? And that's supposed to be a 1 there. And then find out what this x sub beta is that gets you to 2, -5. So it is possible to do this by augment and solve, but this is asking us to do it in a different way. So it's asking us to find the inverse matrix. So if this is the p sub beta, so I'm going to find p sub beta inverse, which is, it would be determinant, so 5 subtract 6, so that'll give me -1, 1 over -1, right? So I switch the order of these two, and I take the opposite of these two, so this is my matrix, right? This is my inverse matrix. So let me just multiply that in. So -5, -3, -2, -1. So that's my inverse matrix. So what am I solving? So again, it's the p sub beta times this beta coordinates matrix that gives me the x, right? So I'm solving for this. So I'm solving for this. So I'm going to take the p sub beta inverse and multiply it times my vector x. So -5, -3, -2, -1 times my vector x. And I do matrix multiplication, and I get 5, 1. So this is my beta coordinates vector.